Right now, as you are hearing these words, an object roughly the size of a small car is hurtling through the absolute, freezing void of space at over 37,000 miles per hour. It has already traveled more than 15 billion miles away from Earth. Despite the staggering distance, this machine is still transmitting signals back home. But home is so far away that those signals, traveling at the speed of light, take nearly 22 hours to reach our antennas. They tell us stories of places where no human-made object has ever ventured before. We're talking, of course, about Voyager 1. And what it's discovering right now is completely shattering everything we thought we knew about the boundaries of our solar system. Let's take a step back to September 5th, 1977. A Titan III rocket roared to life at Cape Canaveral, carrying 725 kilograms of the most advanced technology of its time. Voyager 1 was on its way, followed shortly by its twin, Voyager 2. The mission was simple: explore the outer gas giants, Jupiter, Saturn, Uranus, and Neptune. NASA engineers were hoping for maybe 5 years of operation. The electronics back then weren't designed to last decades in the harsh environment of deep space. The onboard computers had memory measured in mere kilobytes, and the power came from plutonium-fueled generators that slowly decay over time. Fast forward 46 years, and both probes are still alive. They have far outlived their creators' wildest dreams. But as they pushed further out, the data they started sending back began to get weird. To understand why, we have to look at what we were taught in school. For decades, the solar system was described as a neat package: the sun, 8 planets, and an asteroid belt. We thought the edge was somewhere just past Neptune, followed by a vast, empty, and silent interstellar ocean. Science predicted that outside our solar system, there was an absolute vacuum, maybe 1 or 2 hydrogen atoms per cubic centimeter. We visualized the space between stars as a nothingness. This vision was the foundation for every interstellar theory we had. But as it turns out, our sun isn't just a light bulb in a dark room. It's a dynamic force that creates a massive bubble around us called the heliosphere. The sun constantly blasts out a stream of charged particles, protons and electrons, known as the solar wind. This wind blows at speeds up to 500 miles per second, carving out a sanctuary in the galaxy where we live. The theoretical boundary where this wind stops is called the heliopause. We expected this to be a clean, sharp line where the sun's influence simply vanishes. We thought that once Voyager crossed this line, it would find peace and quiet. But when Voyager 1 finally hit that wall on August 25th, 2012, it didn't find a peaceful void. It found a turbulent, high-pressure battleground that left scientists in a state of shock. When Voyager 1 crossed the heliopause and officially entered interstellar space, the scientific community held its breath. For the first time in history, a man-made object was sampling the galaxy directly. And the first thing the instruments reported was a massive contradiction to every model we had. The interstellar medium wasn't empty. In fact, the plasma outside was significantly denser than anyone had calculated. As Voyager moved further away from the sun, the electron density didn't drop. It actually started to rise. By 2020, probe was reporting plasma that was 40 times denser than what we see inside our solar bubble. This was a catastrophe for existing theories. Space between stars was supposed to be a vacuum, yet here was Voyager, plowing through a thick, ionized soup of particles. But the density wasn't the only mystery. The The second big discovery was something far more eerie. Voyager heard something. Now, sound can't travel through a vacuum in the traditional way because there's no air to vibrate. However, plasma, which is ionized gas, can carry waves of pressure. Voyager's instruments can detect these electromagnetic oscillations and convert them into audio frequencies. What the scientists heard was a constant, low frequency, and incredibly persistent hum. Imagine a single, monotonous note being played by the universe itself. This isn't the silence we expected. This is a 3 kilohertz buzz that fills the space between stars. Some call it interstellar humming. At first, researchers thought it might be a temporary disturbance, like an echo from a distant supernova explosion that happened millions of years ago. But the hum never stops. It doesn't change its pitch, and it doesn't fade. It's as if the entire galaxy is tuned to a specific, haunting frequency. This discovery changed our fundamental understanding of the void. We used to think of interstellar space as a passive stage, but Voyager is showing us it's an active, vibrating medium. The fact that the pitch of this hum is so stable suggests that the density of the galaxy is remarkably uniform over vast distances. Usually, gas and dust in space tend to clump together into clouds, creating variations. But Voyager is flying through what looks like a perfectly mixed cocktail of matter. And then there's the boundary itself, the heliopause. We used to picture it like a wall. On one side, the solar system. On the other, the galaxy. But Voyager showed us that this border is actually a massive, turbulent transition zone that is billions of miles wide. The solar wind doesn't just stop. It mixes and churns with the interstellar plasma. It's a chaotic mess of magnetic fields and particles from 2 different worlds colliding. What's even more fascinating, this boundary is alive. It breathes. When the sun is very active, the bubble expands, pushing the boundary further out. When the sun calms down, pressure from the galaxy pushes back, and our bubble shrinks. Voyager was essentially trapped in a pulsing membrane for months, crossing the line over and over again as the sun breathed against the darkness of the cosmos. For decades, we looked at our solar system through the lens of a simple, static map. We imagined the heliopause, that final frontier where the sun's influence ends, as a clean, sharp line in the sand. On one side, home. On the other, the deep, dark galaxy. But when Voyager 1 actually arrived there, it found something far more complex and, frankly, more terrifying. The boundary isn't a wall. It's a living, breathing membrane. During the final months of its exit in 2012, Voyager 1 experienced a strange dance. The solar wind would vanish, replaced by interstellar particles, only to return a few days later. It was as if the probe was moving in and out of the solar system without changing its course. Scientists soon realized that the heliopause was moving past the spacecraft. Our solar bubble breathes in response to the sun's 11-year cycle. When the sun is active, the bubble expands, pushing the boundary outward. When it calms down, pressure from the galaxy pushes back, and the bubble shrinks. Voyager was caught in this massive, slow-motion pulse, proving that the edge of our world is a dynamic, constantly shifting battlefield. And then, there is the shape of it all. We used to think the heliosphere looked like a comet, with a rounded head facing the direction of our travel and a long, trailing tail behind us. It was a neat, logical model. But Voyager 2, which exited the bubble in 2018 from a different direction, sent back data that threw this model out the window. The density of the plasma and the direction of the magnetic fields were completely different than what Voyager 1 had seen. Instead of a symmetrical comet, scientists now believe our solar system's shield might look more like a croissant, or even a jellyfish. It is a deformed, squash structure, compressed on one side by the galactic wind and stretched irregularly on the other. The difference in density between the two exit points was nearly 20%. This discovery means we aren't living in a stable bubble, but in a fragile, swaying cocoon that is constantly being reshaped by the unseen currents of the Milky Way. Voyager also discovered a magnetic foam at the edge, massive bubbles of magnetic energy, some as large as the distance between the Earth and the Sun. These bubbles act like a turbulent sieve, churning the particles that try to enter or leave. It's a chaotic transition zone that is billions of miles wide. We aren't just isolated in space. We are protected by a chaotic, high-energy shield that barely holds back the pressure of the interstellar medium. Every day Voyager sends data. It reminds us that our home is just a tiny, flickering candle in a very windy and very large room. As Voyager pushes further into the interstellar medium, it isn't just flying through space. It is flying through a graveyard. The medium between the stars is filled with the debris of civilizations and stars that died billions of years ago. One of the most profound things Voyager has measured is the intensity of cosmic rays. Inside our solar bubble, the sun acts like a 50% shield. It deflects half of the high-energy particles that are constantly trying to bombard us. Outside, in the open galaxy, the radiation is twice as strong. These particles, mostly protons and nuclei, were accelerated to near-light speed by supernova explosions. They carry the history of the galaxy's most violent events. Voyager's detectors found something haunting: isotopes like iron-60. On Earth, iron-60 doesn't occur naturally. It is only created in the furnace of a supernova. We found it in the deep-sea crust on our planet, and Voyager is finding traces of it in space. This is proof that about 2 million years ago, a star exploded within 300 light-years of us. Our solar system is currently sailing through the local bubble, a cavity in space blown out by that ancient explosion. Voyager is sampling the literal ashes of a dead sun that lived and died long before humans even existed. Probe also bore witness to the terrifying power of magnetars. In December 2004, a massive burst of gamma rays from a distant star, SGR 1806-20, hit our solar system. Even though it was 50,000 light-years away, it ionized the Earth's atmosphere in the middle of the night. Voyager, sitting out on the edge, recorded the shockwave. It showed us that we aren't just affected by our neighbors, but by cataclysms on the other side of the galaxy. This is the weather of the interstellar medium. It's not a void, it's a restless sea of energy. Scientists worry because geological records show that Earth has experienced massive extinctions that correlate with high levels of these cosmic rays. If the heliosphere ever weakens, and Voyager shows us it is an unstable structure, life on Earth could face a radiation crisis. Voyager isn't just an explorer, it's our early warning system. It is the first machine to feel the pulse of a galaxy that is far more violent and far more connected than we ever dared to imagine. We are children of the stars, but Voyager shows us that the parents can be incredibly dangerous. But as we speak, clock is ticking for our farthest messengers. Voyager 1 and Voyager 2 are running on borrowed time. Their hearts, those radioisotope thermoelectric generators fueled by decaying plutonium, are slowly growing cold. Every year, probes lose about 4 watts of power. To keep the essential transmitters and heaters running in the absolute zero of deep space, NASA engineers have had to make heartbreaking decisions. One by one, the scientific instruments are being switched off. First, the cameras were silenced. Then, the heaters for the remaining sensors were cut. By the year 2030, power will likely drop below the threshold needed to send any data at all. Voyager will fall silent. The 22-hour whisper that connects us to the edge of the galaxy will finally fade into the cosmic background noise. But the end of the mission is not the end of the story. Even when the electronics are dead and the antennas are cold, Voyager will continue its journey as a silent, silver ghost. Attached to the side of each probe is a gold-plated copper disc, the Golden Record. This is humanity's ultimate time capsule. It contains greetings in 55 languages, the sounds of a heartbeat, a mother's kiss, and a thunderstorm. It carries the music of Bach, Chuck Berry, and Navajo chants. It holds a map of our position in the galaxy relative to 14 pulsars. The Golden Record wasn't really designed to be found. The odds of an alien civilization intercepting a small piece of metal in the vast, empty ocean of the Milky Way are practically zero. Instead, the record was a message to ourselves. It was our way of saying, we were here. We mattered. We dreamed of things bigger than our own survival. In about 40,000 years, Voyager 1 will pass within 1.6 light-years of the star Gliese 445 in the constellation Camelopardalis. By then, humanity might have conquered the stars, or we might have long since vanished. But Voyager will still be there. It is built to last for billions of years. Long after our sun has expanded into a red giant and swallowed the Earth, Voyager will still be drifting through the interstellar medium. It will be a testament to a species of curious primates who lived on a small blue planet and dared to challenge the infinity of the void. What Voyager discovered in its 46-year journey has changed our fundamental understanding of our place in the universe. It showed us that we live in a fragile, pulsing bubble, protected by the breath of our star against a galaxy that is far more active, dense, and noisy than we ever imagined. It taught us that empty space is a myth, that the cosmos is a vibrating, singing, and turbulent ocean of plasma and magnetic fields. But perhaps the most important lesson Voyager gave us was a sense of perspective. It taught us that we are all passengers on a tiny, beautiful, and incredibly lonely pale blue dot. As the probes move further into the darkness, they remind us that the boundaries of our home are not fixed. They are something we must define for ourselves through exploration and curiosity. Tonight, when you look up at the night sky, think of that small car-sized machine, 15 billion miles away, still whispering its secrets across the dark. It is the spearhead of our species. It is our hope cast in metal and plutonium. And even when it finally goes silent, it will never truly stop. Voyager will carry the memory of Earth into the deep time of the galaxy, forever a part of the interstellar medium it worked so hard to discover. The journey continues, even if we aren't there to hear it. Thank you for joining us on this voyage to the edge of the known. If you found this story fascinating, don't forget to subscribe and keep looking at the stars.